Hello everybody, Brody here. Today we're going to be looking at the severe weather potential for June 17th, 2026. We have it pulled up right here. Um, Currently a moderate level 4 out of 5. The SPC is issued for central Illinois into northwestern Indiana. All hazards on the board here with a 15% SIG 2 for tornadoes, 30% SIG 1 for damaging winds, and same thing, 30% SIG 1 for damaging hail. Let's look at the tornado risk. We got a 15% SIG 2 extending from central Illinois into eastern Illinois to northwestern Indiana. We got a 10% SIG 1 covering most of Illinois, so specifically central to northern Illinois, and then over into eastern Illinois, northeastern Illinois, and as well as northwestern into northern Indiana, and a little bit of Missouri down here. So all hazards on the board for tomorrow, June 17th, 2026. Let's go ahead and dive into the science behind it. So the first thing I want to look at is the observed 500 via SPC mesoscale analysis page. You can see this is right now we have a bit of a long wave trough extending over a good a lot of the Midwest. It has some really some northwesterly flow across parts of the Dakotas into Nebraska, Wyoming, Montana. That's going to be this jet streak up here is going to be the player of Synoptic wise in tomorrow's moderate. First thing that really catches my eye is there is a trough and then there's a ridge here of high pressure. Typically, you would want to have these two switched. You would want to have the trough and the southwestern North America, and then the ridge up in the eastern part, northeastern part of North America. So right now, that's something I could see that could potentially tinker with severe weather potential, specifically for tornadoes. But it's not major. But typically, you would want these two to be vice versa for the severe weather potential to really skyrocket. We are still a day out from the risk from the day. So what I like to do if we're not on the same day is compare models. So we have the H triple R, the HT up, H triple T here, and we'll go ahead and go into early to mid afternoon of tomorrow. You can see that the 500, the northwesterly flow just completely overspreading the area of concern. There's not much of troughing going on. It's more of just northwesterly flow. There's no kind of trough, which is okay. There's a little bit of a 500 low up here, which that is going to play a nice factor. But in June, so it's currently mid-June, June 16th. The day of tomorrow is going to be June 17th, 2026, and for June, you don't need much troughing going on. for June. You this 500 flow right here. This is more than enough. This is more than enough for specifically tornado genesis, getting storms fired up. This 500 is more than enough of a synoptic forcing for tomorrow's risk that is really going to help get things going. I do see maybe perhaps a little bit of a shortwave going on. Looks, yes, I believe that is a shortwave that's going to be injecting over central Illinois tomorrow. This is at 4 p.m. Central. As the time of making this, as you can see down here, it is currently 9:26 a.m. Central Daylight Time, the morning prior to the area of or to the day of the day. So here in Texas, currently 9:26 a.m. Central is when we're looking at our models here. So it looks like there's a little bit of a shortwave that's going to be injecting into central Illinois. That could really help. That could act as another even more of a forcing mechanism to get these storms up and fired. Here is our 800 millibar low-level jet. You could see that the shortwave is definitely imminent in the lower levels as well. Has some southwesterly flow across the Midwest. That's going to be dragging these some better dew points, and they're going to be lots of moisture return in mid-afternoon, and as well as surface heating is going to help destabilize the atmosphere very fast. That's going to help and aid in these storms maturing both quickly and their updrafts rotating fairly quickly to get tornado genesis. It's everything is looking at this low level jet, this 500 or this 850 millibar is really impressive to me, especially with the lower dew points that we have down here. Prior is going to be just a lots of really nice moisture return throughout the day tomorrow, getting the low level upper air is going to be a really nice moisture transport, and that's going to aid significantly in this tornado risk, with as well as the wind and hail as well. We can look at our mixed layered cape here. This 4 p.m. Central. Lots of instability here in central Illinois to northern Illinois, covering pretty much all of Illinois, lots of Indiana, into Missouri as well. If we go ahead and animate it here, you can see 5 throughout the early morning. Not very. It's the atmosphere is still decently stable, but throughout the day you can see the surface heating is really going to help destabilize the atmosphere rather quickly, which is going to aid in these storms becoming very robust very quickly. We can go ahead and look at our current surface observations. We do have a bit of a surface low down here on the Texas coast. This is because if we so we can see a bit of a tropical depression starting going here on the Texas coast, and this could actually potentially hurt our moisture transport for tomorrow, because surface this is causing a surface low pretty much, and instead of having our moisture transport coming up here to the area of concern, to the area of concern up here into Illinois, it's actually getting these dew points. You can see a 76 over 76, 74 over 74, very deep moisture in near the Texas coast into the Louisiana coast. It's just this tropical depression here, but since this low is going to be moving counterclockwise like lows do, this actually might take all this deep moisture here and keep making it go around the surface low over and over again, and just keep aiding up. It might be pulling these dew points here and helping it aid in forming into potentially a tropical storm, because it's currently a tropical depression. But that could be a little bit that could hurt our risk for tomorrow, hurt our moisture transport. Just something to keep in mind. This is 3 p.m. tomorrow via the HRRR model. It is in the surface analysis here. Looks like we actually have a low pressure, a surface low over central to north central northern Illinois, which that could actually, I do like the way the fact that this is actually here, because you see a bit of a why does it keep getting like that? I don't know. You can see a bit of a pressure tongue here, and as well as down here. So this is gonna be the cool front. This is gonna be a cool boundary. This is gonna be moving into these moving southeast, as well as this warm front, you could call it. It's gonna be moving almost due north. Gonna be southeasterly, maybe east southeasterly, and then we're gonna have this sector right in here. This is gonna be our warm sector, and it's going to aid. This is gonna be our biggest aid in tornado genesis for tomorrow. This very rich moisture, this deep moisture is going to be very favorable for to help these storms become robust fairly quickly. If we go ahead and look at our dew points here, we'll see. There we go. Okay. So the HRRR is simulating very effective moisture return, surging in from the southwest throughout the day, just in time, just prior to storm initiation. So this moisture transport is really going to get these storms going to be firing off this off this cool frontal boundary here. Upwards of mid-70s dew points in central Illinois, which is way more than enough to aid in these robust storms. If we can go ahead and take a sounding, we'll see what we potentially have. Okay, we have a little bit of a capping inversion here at the 700 to 600, which because of the surface heating, I don't think that's going to be much of a problem. I think this could erode fairly quickly. Very, very impressive dew point to temperature spread. That's impressive. That's the fact that these two are less than even 10 degrees apart is almost explosive, actually. So this temperature and dew point spread is more than favorable for tornado genesis and really helping these storms mature very quickly and become very robust. Mixed layer Cape, upwards of 2400. We have a pretty thick instability profile here. It's quite impressive, actually. And the lapse rates, much more. I glanced at the lapse rates earlier this morning. The lapse rates are much more impressive than they were looking earlier, which that very, very steep lapse rates all the way up, really. That's going to aid in an instability. That's going to be also because of the rapid surface heating and resulting in major and rapid destabilization of the atmosphere. Let's take a look at this photograph. This is a classic supercell setup. Absurd amount of low-level wind shear to the 0.5 kilometers in the atmosphere. That is a surge of, what is that? It's about 30-ish, 25-ish knots before we even just about half a kilometer up into the atmosphere. That is very, very impressive low-level wind shear wise. The half a kilometer to 1 kilometer is not very much, but that is okay because the amount of low-level wind shear we have, 1 to 3 is it's okay, and then the what I really like about this sounding is the venting. There's a amazing venting going on to help these storms really be able to inhale and exhale without choking themselves out. This is definitely leaning more towards a classic supercell setup. If anything, might be leaning more towards a little bit of a high precipitation setup, but from this specific sounding or in this photograph here, this is definitely a classic, very classic textbook supercell setup. That's actually quite impressive. We can look at our storm relative helicity here, upwards of 500 meters squared per second squared. Through the 0 to 6 kilometer range. That's quite impressive. We have more than enough of storm relative helicity all throughout the atmosphere, which is going to aid significantly in helping these storms become robust very quickly. This is our pretty much our shear rate here. We have our 0 through 1 kilometers, 33 knots, and then 28 knots, 32, 21, 20, 28, which it usually is going to get a little bit lower, especially with this the higher you get in the atmosphere here. But this is good. This is quite impressive. This is more than enough for tornado genesis. And 73 3-kilometer instability, 3-kilometer cape. More than enough. Typically, I'd like to see a little bit more. 3-kilometer instability. especially the day of. But due to the rapid destabilization via surface heating tomorrow, there should be no problem. Even if it were to stay at the amount that the HRRR sounding is depicting, that's more than enough. But I would bet that because of the surface heating tomorrow, this 3 kilometer instability is going to at least get over 100. Another thing is we could see this little bit of a capping inversion here. Surface heating should have no problem eroding this, especially with the amount of storm relative helicity and synoptic lift. If this were to not erode this cap for whatever reason, these updrafts would have no problem pushing through and breaking through that cap. I have a little bit of convective inhibition here. Like I said, should not be much of a problem, because if it were to not erode for whatever reason, I don't think these storms are going to have much of a problem pushing through the cap. We can go ahead and compare models here. Here's the 4 p.m. or 21 Zulu Central HRRR 500 millibar. And we could also look at the Rufus. They are pretty much agreeing. What I want to see if they are agreeing models. Let's check out the NAM wrap. They are GFS. They do seem to be agreeing on at least a little bit of a shortwave going on across Wyoming into northeastern Missouri. So that makes me think that this shortwave is by far going to be imminent. If we come look at the 500, current 500, we don't see much of that shortwave. Maybe this could possibly be it right here. We'll have to see how this plays out. But this jet streak up here is going to be the player in this 500 millibar synoptic forcing, at least for tomorrow. Big long range trough here, and like I said earlier in the video, one of the first things I said is this is more than enough to get storms kicked off in June. You don't need much synoptic wise in June for them to really get going. One thing I do want to glance at real quick is the 700 millibar temperature height with wind. And in June, the most you would want to have 500 millibar temperature wise is anywhere from just 12 to 13 Celsius. Anything more than that, it's going to be too much of a capping inversion. 700 is going to be too capped off for storms to really get going. So here's 4 p.m. Central tomorrow, 21 Zulu. This is impressive. There's not going to be much of capping and inversion at all, really, the 700 millibar wise. Here's 4 p.m., 5 p.m., 6 p.m., 7, 8, 9. This is impressive 700 millibar temperature wise. These storms should have no problem getting up and going and getting robust fairly quickly. I do want to look at the NAM models on pivotal weather on the surface-based convective available potential energy, as well as photographs. So we'll go to 21 Zulu tomorrow. This is here we go. 21 Zulu tomorrow. Here's 7. Go ahead and take a sounding right here in central Illinois. See where we're going. Very impressive photograph here. Lots of low level directional shear and speed shear, wind shear. This is leaning more towards a little bit of a high precipitation setup. I am realizing that there's a little bit of contamination here, so we'll go ahead and pluck another sounding and see if we can get something better. Still contaminated. So okay, here we go. This is a good sounding here. So the lapse rates down here at the bottom left is this is what I was talking about, what I was looking at earlier. Not very steep, but the surface heating should not have a problem in destabilizing the atmosphere. 7.9 Celsius per kilometer mixed layer lapse rates is quite impressive. So the first thing I notice here is it's pretty saturated here in the low levels between the 850 and the 700. Pretty saturated. Oh my gosh, saturated. Excuse me. 73 over 71. Extremely impressive temperature spread. Way more than enough. That's overkill, really, for getting the storms kicked off. 73 over 71 is rather explosive. Do have a bit of dry air aloft, which should not be much of a problem whatsoever, which I don't think that's going to be a problem at all. This is just looking at the specific sounding. You can see the 0 Celsius, and you can go over on the contour of the 0 Celsius. There's not really any saturation above this 0 Celsius contour here, which makes me think that and this where the specific sounding is here, you can see the coordinates here, isn't going to be much of a hailer because there's not much saturation above the 0 Celsius contour here on the SQT. But we'll see how it plays out. Upwards of 412 meters squared per second squared storm relative velocity, which is impressive, very impressive. And upwards of 300 mixed layer cape with a rather thick instability profile here, as well as his decently low LCLs. The fact that the LCL is so low could make wall clouds, the storm bases, rather low based and help anything get on the ground quickly. So, Wednesday, June 17th, 2026, looking rather explosive, I would say, with the 15% sig 2. That's quite impressive. There are a few factors that could potentially hurt the severe weather potential, specifically for tornadoes. But for the most part, it's looking very explosive. Strong, intense tornadoes are certainly possible across central Illinois into northwestern Indiana. So if you're in this spot, if you're in this area, or know anyone that's in this general vicinity, just make sure you are weather aware for tomorrow, because this could potentially be very catastrophic, very very damaging, very dangerous. For the most part, that's pretty much all that I want to cover as of right now. Might do another discussion here later this evening, and more than likely we'll be doing one tomorrow morning. Here's just a quick little overview of tomorrow's risk. 15% SIG 2 from the SPC is quite impressive. So that's it for today. I'll catch you guys in the next one. See ya.